Hi there, it's time for Physical Sciences once again on Matrix Uploaded. My name is Tinyiko Kosa and you are welcome from grade 10 to 12 to be part of this lesson. And today it's lesson number 35. I am going to talk to you about conservation of linear momentum and projectile motion. Okay, and let's have a look quickly at grade 10 level. Let's just recap on what we did around acceleration. That this is the rate at which velocity changes. Okay, and let's see if we can do some examples here. A car traveling west at 4 meters per second increases its velocity to 10 meters per second in 3 seconds. What is its acceleration? Acceleration is v final minus v initial divided by delta t. So that will be equal to v final is what? 10 meters per second minus v initial is 4 meters per second. In how long? In 3 seconds. So t is 3 seconds. So you've got 6 over 3, and that is 2 meters per square second. Okay. Now, example 2, a car traveling at 120 kilometers per hour, reducing its velocity to 8 kilometers per hour in 4 seconds. What is the acceleration? Now convert this into meters per second. 120 divided by 3.6. Remember what we did earlier on? Okay, so I mean in the previous lesson, divided by 3.6. Okay, and that is 33.33 meters per second. And this 80 is going to be 80 divided by 3.6, and that should give us 22.22 meters per second. Okay, so when we find acceleration is v final minus v initial divided by change in t. That should be equal to v final is 22.22 minus v initial is 33.33, and then you divide it by 4 seconds, and what we get? Okay, so that will be minus 33.33. That will be equal to that divided by 4. Okay, and the answer is minus 2.78 meters per square second. Minus means the acceleration is in the opposite direction, so it's 2.78 meters per square second in the opposite direction. Okay, in the opposite direction. That's what that negative means. We assumingly taking the direction of motion to be positive here. Okay, now let's come to something very important as well. Change in momentum, which is something we did earlier on, but we're bringing in the question of impulse here. Change in momentum is called impulse, and impulse is the product of the force that acts on that object causing that change and the time interval when the force is in action. So impulse equals F delta t. And from F delta t, because we're saying this impulse here is change in momentum, so it should be m into v final minus v initial. Okay, so this F here, the force that causes that change, which is of course what we call resultant force according to Newton, should be given by the rate of change of momentum, as you see here from that formula there. That is very important to understand. And from this, we move on to stating Newton's law in terms of momentum. Okay, so this Newton's second law of motion in terms of momentum can therefore be stated in this way. Remember, resultant force, okay, is that according to Newton's second law of motion. But then when we look at impulse, we come to see that this resultant force we're talking about acting on an object is equal to the rate of change of momentum, and of course in the direction of the force in that way. So if you're asked to state momentum in terms of, Newton's second law in terms of momentum, this is what they want you to do. Okay. Change in momentum is experienced in our everyday lives during collisions. Okay, so modern cars, for that reason, have got features that are specifically built in for our safety. Okay, things like seat belts, we have to buckle up every time we get into a car so that we don't fly off when accidents happen. We become part of that car. Crumple zones, you see small cars these days, even the big ones, but let me give an example of small ones. They have got big shapes, but they are small. That shape there in front, on the sides, and even at the back is what we call the crumple zone, so that when the accident occurs, it takes time for that crumpling of the car to occur. And the longer the point of contact between the car and whatever it is hitting, or another car if the collision is with another car, if that time is longer, it reduces the force. Look at where the force is. If this time here is longer, then you're making the force less. Now, this force is the force that causes that impact, the injuries and everything. So if that force is less, you are sure that people inside this vehicle are going to be safe. And that is why all these safety features become very important. And the last one, of course, is that of airbags. Let's meet in the next section of the lesson.